Exponential functions, half-life, word problems application. So in this exercise we have a problem that needs to be solved. There will be two ways in which we will approach solution to this question. So what we have here is half-life of a certain substance is 4.1 days. So half-life can be measured in days, in years, or in different units like hours, minutes, and so forth. So we will have to find out the time that is required for that substance to drop from 30 grams to 10 grams. So what you see here, there's two similar functions, similar formulas that we can use and achieve the same result. So let us look at the left side of the screen. You have a exponential equation here where the base is e, so recall that's base of a natural logarithm. Then we have an exponent k multiplied by t. T is the time, so the function p is a function of time. P0 represents the initial value of the substance in terms of mass or maybe count. So in this particular problem, P0 represents 30 grams. PT value is equal to 10. K is the number that we have to find first before we find the time here. So K is called continuous exponential growth or decay rate. So that rate has to be found first. So let's go for it and find what is the value of K. The time in this particular exercise we'll use as 4.1 days. So T is equal to 4.1. So now you can see that I have left hand side taken care of because that's the number 10. P0 is 30. T is 4.1, and we'll find that continuous exponential decay rate in this particular equation. So let's plug in and find the value. Now, correction. Since T represents a half-life, 4.1 days is a half-life, so P0, if P0 is 30, P would be 15. So let me change that here. P is really 15 because the time that we use is half-life time, and we need to find what is the growth or decay rate in this case. So the left side is 15, not 10, is equal to 30 e to exponent k times 4.1. So technically you should see 4.1 k divided by 15, by 30, because I don't want to see this this coefficient here, by 30. So the left side is 0.5, the right side is e to 4.1 k. Now apply logarithm and find the value of k. So the logarithm here that we will apply to both sides will be natural logarithm, so ln 0.5 is equal to 4.1 k natural logarithm e. So applying the power rule, 4.1 k exponent is factored out. This is why you see 4.1 k, so this is k, times ln e. ln, natural logarithm of e, is just 1. So this is why the right hand side will be 4.1 k, and the left side is natural logarithm of 0.5. To find k, you would simply divide both sides by 4.1, and k is equal to, when you use your calculator, -16906. Now, k is negative, which makes sense. So this is the decreasing type of function. So when you have negative exponent, you expect to decrease the value of p0 to any number except for 0, of course. So now the rate is figured out, and now we have to find the time that is needed for 30 grams to shrink into 10 grams. So now you'll find that the left side is 10, the right side is 30, and this is e to the negative exponent 0.16906 times t. So to solve this equation, we will have to divide both sides by 30, apply logarithm, natural logarithm, and then isolate for t. And in the process, you will see, when you use your calculator, that t is approximately 6.5. So 6.5 is the final figure for t using this approach. Using the equation provided on the right hand side of the screen, we will see that now the base is 1/2, the exponent is t over h. H represents half-life time, which is 4.1 days in our case. So we have to find the time that is needed for 30 grams to shrink to 10 grams. So many times you're going to be using this type of formula where the base of the exponent is half. Or you can use that continuous rate formula where the base is e. So you have a choice. Sometimes you don't remember half-life formula, you must then know the formula that involves e to exponent kt or vice versa. But in either case, you will be able to solve that question and get exactly the same result. So this solution on the right hand side will be a little bit faster because we have almost everything and we need to find only one variable t from that equation. So the left side is 10 is equal 30 to times 1/2 to exponent t divided by 4.1. Now, we didn't quite solve that value of t on the left hand side of the screen, but the process will be exactly the same from this stage. So both sides divided by 30 to simplify the equation. So we have 1/3 is equal to 1/2 to exponent t over 4.1. Apply logarithm. So we can apply log to base 10 this time. So log 1/3. You could also select natural logarithm for that as well. The answer will be identical. So this is log 1/2, and t over 4.1 by the power rule will be factored outside. So find t. Now you multiply, this is the fraction t divided by 4.1. Multiply by 4.1 both sides of the equation. So 4.1 times log 1/3 divide by log 1/2 should give you t, just by rearranging the equation. Or you can say multiply both sides by 4.1, then divide both sides by logarithm 1 over 2, so the right hand side will give you t. Use a calculator and you'll see that t is approximately equal to 6.5. So this is the same amount of time as on the opposite side, 6.5 days. And it does make sense because half-life is 4.1 days. Since you're shrinking more than 50%, so it should take you longer than 4.1 days. So that's where you can sort of reason possible answer or not. I hope you have enjoyed watching this solution, and I see you next time.